Lesson 5, I will use addition and subtraction to solve multi-step word problems involving length, mass, and capacity. So this is the final lesson in this module. And in this lesson, we're putting together all the information that we've learned in the other 4 lessons, and we're putting together some problem solving. You're not going to need your math journal today. You just need to get out your problem set because we're going to go right straight to the problems today. So with our problems, we are going to be using the RDW process that we've been using. We're going to read, we're going to draw something, we're going to write a number sentence, and then we're going to write a word sentence. So the first thing that we're going to do is we're going to read this problem. The potatoes Beth bought weighed 3 kilograms, 420 grams. Her onions weighed 1,050 grams less than the potatoes. How much did the potatoes and onions weigh together? So the first thing I want you to do is I want you to model the problem. Think about how can you show how much her potatoes weighed, and then how can you model that her onions weighed 1,050 grams less than the potatoes. And then I want you to put a question mark on what the question is asking you. What are you trying to solve? Once you get your problem modeled, if you think that you can go ahead and solve the problem by yourself, go ahead and solve it and then check back for the solution. Okay, so you're going to notice that I have 2 different solutions here. They both get the exact same answer. I just want to walk you through this really quickly. So you can see here that I modeled the weight of the potatoes, and then this is the weight of the onions. So the V represents the weight that I did not know. I do not know how much the onions weigh. All I know is that it's 1,050 grams less. That's why there's this empty space here. So to find out how much the onions weighed, I subtracted. And in order to be able to subtract 1,050 grams from 420 grams, I had to decompose one of these kilograms into 2 kilograms and 1,000 grams. Then I was able to subtract. So once I knew the weight of the onions, all I had to do was add the onions plus the potatoes, and that's what I did over here. So the potatoes and onions weigh 5 kilograms, 790 grams. Now the second solution gives me the exact same answer, and you can see that the model is very similar. I showed the potatoes, the onions, and I'm just trying to find out here. The only difference is that before I tried to find out how much the onions were, I went ahead and changed the potatoes to straight grams, to 3,420 grams. And then I used a simplification strategy. I took 1,100 and separated from 2,320. Together, those numbers equal 3,420. The reason for doing that was I knew I could take away 1,050 from 1,100 without having to work anything out, and that would only leave 50 left. Now all I had to do is add these 2 numbers together, and if you'll notice, I got the exact same answer here for the weight of the onions as I did up here, except up here it's 2 kilograms, 370 grams, and here it's in total grams. Then, when I went to add those 2 amounts together, I decomposed this into 2,370, and I decomposed this into 3,420 because I knew I could add my thousands easily in my head and get 500, and I could add these hundreds and tens pretty easily. And again, I got the exact same answer. This is just 2 different strategies. Maybe you used a completely different strategy but got the same answer, and that's perfectly fine. Let's look at problem number 2. Adele let out 18 meters, 46 centimeters of string to fly her kite. She then let out 13 meters, 78 centimeters more before reeling it back in 590 centimeters. How long was her string after reeling it in? It's really important that you model this problem. And when you first read it, it sounds a little bit confusing. But if you draw a model and think about, okay, this is how far she let out her kite to begin with. Then she let out 13 meters, 78 centimeters more. Then she reeled it back in 590 centimeters. Think about how you can model that problem. Once you model it and you feel confident in your number sentence, go ahead and solve it and then check back for the solution. If you get stuck, you could always check back and I'll get you started. Okay, so first of all, I want you to take a look at my model. And this might look a little bit confusing to you at first, but what I did was I made a tape diagram of how much string she let out. This is how much she let out altogether. Then I backed it up a little bit for how much she reeled in because she went backwards 590 centimeters. And then this is the portion I'm trying to find out. I want to know how long her string is after she reeled it back in. So this is the missing part. So in order to find out that missing part, I went ahead and added together these 2 amounts, and I got 31 meters, 124 centimeters. And then because I didn't want to leave this as an improper number, because 124 centimeters can be converted to meters, I went ahead and pulled out a meter from that 124 centimeters and made that 32 meters, 24 centimeters. So I had 32 meters, 24 centimeters. So the string was 26 meters. Oh, I forgot. I skipped a step. So once I found out how long the string was altogether, I had to come over here and I had to subtract that 590 to find out how much it was when she reeled it in. So I came over here and I subtracted, and it ended up with 2,634 centimeters. But I wanted to make that meters and centimeters, so I pulled 26 meters out and 34 centimeters. So it's 26 meters and 34 centimeters after reeling it in. So that's one solution. Here's another way to solve the problem. You can see that I took the two amounts here that she let out, and in order to add them together, I decomposed these 2 centimeters. I went ahead and added together the meters and gave me 31 meters, and then I broke down these 2 centimeters like this so that I could come up with 100, and then I could come up with another part. So I would have 31 meters, 124 centimeters, and again, I ended up with the exact same answer. And then when I subtracted, instead of trying to do 32 meters, 24 centimeters, I just changed that to 3,224 centimeters. And and if you'll see, I pulled out 1,000 because I knew if I pulled out 1,000 and made this 2,224 centimeters, I knew in this number bond I could subtract 590 from 1,000 by counting up pretty easily. So I just pulled out that 590 from the 1,000, and that left 410. So all I had to do was add these two together. Again, I got the same answer. These are two different strategies for solving this problem. You may have solved it a different way, but got the same answer, and that's perfectly fine. Let's look at problem 3. Cheyenne's barrel contains 6 liters, 775 milliliters of paint. She poured in 1 liter, 118 milliliters more. The first day, Cheyenne used 2 liters, 125 milliliters of the paint. After the second day, there were 1,769 milliliters of paint remaining in the barrel. How much paint did Cheyenne use on the second day? So again, when you read this the first time through, it sounds pretty confusing. So it's really important that you break it down and draw a model. So the first thing I would do is I would draw a tape diagram of the barrel. The barrel contained 6 liters and 775 milliliters of paint. Okay, that's how much it had. Then she poured in 1 liter, 118 milliliters more. So I add that to my tape diagram. Then it says on the first day, she used 2 liters, 125 milliliters of paint. And then after the second day, there were 1,769 milliliters of paint remaining in the barrel. How much paint did Cheyenne use the second day? I would make 2 tape diagrams. And the first tape diagram would show the total amount of paint that she poured in. And in the second tape diagram, I would model how much of the paint she used, and the missing part would be how much she used on the second day. If that makes sense to you and you can model that problem by yourself and solve it, go right ahead. If you would like a little bit of help, you can stay tuned and I'll get you started. Okay, so the first thing I'm going to do is I'm going to kind of cover this up a little bit. I want you to take a look at the tape diagram, because if you were having trouble trying to figure out how to do the tape diagram, this slide could help you. So you can see right here, this is how much paint there was altogether. And then here's day 1. It said on day 1, she used 2 liters, 125 milliliters. So this is what was left after day 1. And then it says on day 2, she used some amount. We don't know how much she used, but we do know that there's 1,769 milliliters left. So this is what we're trying to find out, this missing piece right here. So this is going to be a 2-step problem. See if you can figure out what steps it would take to solve for P. If you still don't know, I'll show you. Okay, so you can see here, the first thing I did was I added these 2 numbers together so I could find out the total amount of paint that was in the barrel. Then I subtracted what she used on day 2. So this is how much paint was left after how much paint she used on day 1. So this is how much paint was left after she painted the very first day. Then I subtracted how much paint was left at the end of day 2. So the missing piece here would tell me how much paint she used on day 2. So she used 3,000 999 milliliters of paint on the second day. And as you can see, I just used the standard subtraction algorithm and the standard addition algorithm. Another strategy that you could have used is you could have used the simplifying strategy. And you can see that I subtracted the 2,125 milliliters from the 6,775 milliliters. So I did not add those two together, and that left me with 4,650. Then I took that 4,650 and I added it to this part. So that left me with 5,768. So it's the same numbers I got here. And then I subtracted the 1,769, and again I got the same answer. Two different strategies. If you don't understand both of these strategies, as long as you understand one, you're on the right path. All right, let's take a look at problem number 4. On Thursday, the pizzeria used 2 kilograms, 180 grams less flour than they used on Friday. On Friday, they used 12 kilograms, 240 grams. On Saturday, they used 1,888 grams more than on Friday. What was the total amount of flour used over the 3 days? So what do you think? Is there something that you can draw? My first thought is I would draw 3 separate tape diagrams to represent each of these days. If you understand how to draw that tape diagram and you can create a problem and solve it, I want you to go ahead and try to do that on your own. If you need some help, stay tuned. Okay. So like I said, I would have drawn 3 separate tape diagrams. So this is Thursday, this is Friday, and this is Saturday. We don't know how much flour they used on Thursday. We just know that it was 2 kilograms, 180 grams less than what they used on Friday. We do know how much they used on Friday because it told us in the problem. And then we don't know how much on Saturday. We just know that they used 1,888 grams more. So you can see on Thursday, the tape diagram is less. It's this much less. On Saturday, it's more. It's this much more. We're trying to find the total of all of these. So the first thing that I did was I subtracted how much flour they used on Friday from the amount that they used less on Thursday so I could figure out how much they used on Thursday. So on Thursday, they used 10 kilograms and 60 grams. Now I've got to figure out how much they used on Saturday. So I added these two numbers together, and that got me 14,128 grams. Now I have how much flour they used each day individually. So now all I have to do is go back and add them all together, and that's what I did here. And that gave me 36 kilograms, 428 grams. Again, I used a different strategy down here. My tape diagram is the same, but because there was 12 kilograms, 240 grams here, here, and here, I did this times 3, and that gave me 36 kilograms, 720 grams. Then I had to subtract the 2 kilograms here and the 1,888 grams here because this is the amount that has to be, this amount has to be added and this amount has to be taken away. So I subtracted here and that left over 292 grams, and then all I had to do was take that away and that left me with the same amount. Again, you may find this solution confusing, and that's okay if you do, but if not, that's just another strategy that you can use to subtract and add. All right, let's take a look at problem 5. Now, you have this problem on your problem set. I want you to read it, and I want you to think to yourself, is there something that you can draw? And I want you to try to solve this problem by yourself. And then if you need help, you can check back. Okay, so I'm going to read this problem. The gas tank in Zachary's car has a capacity of 60 liters. He adds 23 liters, 825 milliliters gas to the tank, which already has 2,050 milliliters of gas. How much more gas can Zachary add to his gas tank? So we know that Zachary's gas tank can hold 60 liters. So that's why our tape diagram has a total of 60 liters. This is the whole. And he added this much to his tank. And his tank already had this much. So we want to know how much more he can add. So we're trying to find the value of G. So the first thing I did was I added these two numbers together, which gave me 25,875 milliliters. And then I subtracted that from 60 liters, which is the same thing as 60,000 milliliters. And that gave me 34,125 milliliters. So because the question says how much more gas can he add, it doesn't say how many more milliliters, it just says how much more gas. So you could have said 34,125 milliliters, or you could have said 34 liters, 125 1.5 milliliters. Both answers would have been correct. All right, let's take a look at problem 6. I want you to try again to read this problem, see if there's something that you can draw, and I want you to think to yourself, can you solve this problem by yourself? If you get stuck, you can always press play, but I want you to try by yourself. Okay, so a giraffe is 5 meters, 20 centimeters tall. An elephant is 1 meter, 77 centimeters shorter than the giraffe. A rhinoceros is 1 meter, 58 centimeters shorter than the elephant. How tall is the rhinoceros? So, my first thought is I'm going to need 3 separate type diagrams here. It gives me the dimensions of the giraffe. It tells me it's 5 meters, 20 centimeters tall. And then it tells me that the elephant is this much shorter than the giraffe, and that the rhinoceros is this much shorter than the elephant. And I'm trying to figure out how tall is the rhinoceros. So the first thing I'm going to do is find out how tall is the elephant by subtracting these two numbers. So once I know how tall the elephant is, then I can subtract the difference between the elephant and the rhinoceros, and that leaves me with 1 meter, 85 centimeters. So the rhinoceros was 1 meter, 85 centimeters tall. Okay, so now you're going to try to do your problem set by yourself. I want you to make sure that you look at your pacing guide, and that you do the practice before you do the exit slip. But when you get ready to do the exit slip, if you want to look back at your problem set to remind yourself of how you solve these problems, that's perfectly okay. Good luck.